Hey everyone, it's Mr. Canfield, AB Calculus, Chapter 20, Part 2. Okay, so last time we talked about how it's all about using these sign charts and figuring things out. Sometimes things look weird. So, as usual, we're going to start. Let's analyze f prime. Well, we have a 0 in f prime at 4, and then another 0 at 3. In between, we have positives. Looks like over here, the y values of this are negatives and negative, and then over here, negative. So it looks like we're going down, we're going up, and then we're going down again. So we're going to have some kind of minimum at -4, and then some kind of maximum at 3. So this is going to be a weird place for us. Well, okay, let's talk about that. That's going to be f double prime, right? So f double prime looks like the slope. Remember, f double prime is the slope of f prime. So positive slope, positive slope, positive slope, all the way up until we hit 1. Because at 1, the slope isn't 0. At 1, the slope is undefined. But we've got positive slopes all the way up until then. And then after that, the slope is negative, and it's a consistent negative. And if you remember from the last video, a straight line is the derivative of a parabola. So I know this is going to be some kind of parabolic thing. So let's see. I'm concave up all the way until we hit 1. So at 1, we switch from concave up to concave down. So that's a good reminder for me. So concave up. Okay, so it's pretty standard then, right? Concave up. So the thing that's going to happen here is that it's going to be a more awkward, oops, not that awkward. It's going to be like a more awkward, like it might be, ooh, it still needs to be a function, but the connection of those two isn't going to be smooth. So that's hard to draw. I don't know if I did a good job at it, but I think the idea, at least, should be there. Okay, let's look at our next one. Let's see, we've got, here's our f prime. So we got lots of positive values until we hit 1, and at 1 we get a 0. So we got positive, then we get 0, and then we have negative. Okay, so at 1, we're going up, we're going down. So that means at 1's when you have a relative maximum. And if you look at f double prime, I was going to say the slope is negative the whole way of this graph, but at 1 we actually have an undefined slope. Things like this right here. Oh, I was saying the highlighter would just work. I guess it doesn't. Things like this right here. A straight up and down slope for just a moment. That's actually undefined. So this is an example of it's not going to be a nice smooth curve. Well, and it says it's concave down. So instead of wait, is it just that? But it says the slope is undefined. I might need to go to Stu for this one. I feel like my brain is missing something. I'm supposed to have an undefined slope here. I thought it was going to be something like this, but those are both concave up. Here, I'm going to cheat. Oh, okay. I was overthinking it. Oh, right. So the concavity is not approaching 0, it's approaching super steep. So instead of what I want to do of like have a nice smooth curve here, we need to say that like it's hard to draw. I don't think they would make us draw something like this by hand. It's just, it's worth thinking about that it's not a nice smooth transition here. Okay, let's keep going. Oh, weird. Okay, so the zeros are here, right, in my f prime. So then that means that we know we've got, let's see, these are positive values. So we have positive values. Then at 1 we have a 0. Then we have negatives. Oh, at 2 it's undefined. And then still negatives until we hit 3 where it's 0. And then positive after. So the thing that's going to happen over here, let's see, we're going up, we're going down, we're going down, we're going up. So at 1 we're going to get a maximum, right, because it goes up then down. At 2, this is actually another critical number, critical point, critical value. Undefined pieces of our f prime also count as critical numbers. So it's negative before, it's negative after. This is probably going to be one of those situations where it's going down and it like does one of those. And the way that we're really going to figure it out is through f double prime. So here, all these slopes are negative. Then we have an undefined slope, and then all these slopes are positive. So that means we've got concave down to concave up. That's going to switch at 2. So, sure enough, let's see. Oh, at 3 we're going to have a minimum, right? So we can go like up. Oof, that's bad. And then at 2, oof. Let's see, and then we go around in circles. All right, let's try again. So I'm supposed to have a maximum here, and then a minimum here. And at 2, I'm supposed to have like a little vertical section. All right. So his will look nicer, obviously. Well, didn't I fail? Oh no! Oh, I was rushing. Oh, I was rushing so bad. Well, I'm glad you got to see that. So this asymptote here, yeah, okay. Oh, I feel silly. So this asymptote, his goes down here and then comes in from the top, right? So the slopes here are going off to the infinities. So, oh, silly me, silly me. This is one of those situations where at first glance you might move that. I missed that by a mile. Why don't I just move it up? Just do what he did. It makes life easier. This is where putting dots on things is helpful if you're a bad artist. So let me just explain this in case you missed why this happened. So there's an asymptote here. These slopes are going off to negative infinity, so we're going to have very, very, very steep slopes. They're going to just get away from us. And then it's a negative slope here. This is still a negative slope. So that's the only way to go from like an infinitely negative slope to continue on an infinitely negative slope. We wrap around the whole universe, end up at the top. Okay, now we've got J. Let's see. So at -2, that's not a zero. Well, hold on. F prime. That is a zero. F prime. We have positives before it. We have positives after it. So now we just have to see what the concavity is. This is what I was looking for earlier. F double prime. We have negative slopes before it, and then we have positive slopes after it, and an undefined slope right there. So at -2, it's not a maximum or a minimum. I'll just put it down here at -2, and it's concave down, and then it changes to concave up. So let's see how that looks if a computer draws it. There's a little bit of a there. Not something we're going to be able to draw very well by hand. So what Stu most likely did was he most likely used a computer to graph the original function and its derivative. So he had an original function in mind. That's how his are looking so perfect. All right. Oh, these are great, great problems. Sketch a possible f of x with the following characteristics. F double prime is greater than 0. F double prime is greater than 0. Okay, so it's always going up, and it's always concave up. And f of -1 is -2. So we have this dot. It's always going up, and it's always concave up. So you might have a hard time drawing it, but like, just make sure it's always a cup shape and it's always going up. There. That's a possible picture. I wonder what Stu's look like. Well, I don't want to cheat and see B yet, so let's see. What about this one? F double prime is greater than 0 when x is greater than 1. Okay. I said F double prime, F single prime. So I'm just going to draw this to help myself. So we got positive slopes over here. Okay, so that means that we're going up over here. And less than 1, it's less than 0. So we're going down. f prime of 1 is 0. Oh, okay, so that means we have a minimum at 0. Let me start at 1. It's always concave up, and f of 1 is negative 1. Oh, it actually tells me the value, so I don't get to pick this time. I have to go right here. Yeah, except, there. All right. So it's always concave up. This is a minimum. Yeah, there, that's it. So you can see by Stu's graphs, he's got similar things. So not too surprising. Cool, we got 4 more. Be right back. All right, so for our next one, let's see, f prime is greater than 0 when x is greater than 2. So f prime is 0. Oh, interesting. It says f prime is 0 when x is less than or equal to 2. So our slopes all the way over here are 0. Those are zeros. Just pretend with me. 0, 0, 0, 0. So it's going to be completely flat, and then it's going to go up after. Okay. F double prime when we're greater than 2 is positive. So it's going to be concave up from 2 on. And f of 2 is 1. So is that going to be just a pretend that's flat line, and then happy with that. And then let's see, f prime is positive when we're greater than negative 1. And okay, and then it's negative when we're less than negative 1. But what is f prime when we equal negative 1? Huh. F double prime is less than 0 and x does not equal negative 1. So it's, we know it's concave down, we know it's concave down. He's not giving me any information about negative 1, so that, let's see, f of negative 1 is negative 2. Essentially this leaves options for me. Well, hey, if we're going down and why don't we just go whoop, and then whoop. Let me see how close I am to what Stu has in mind. Wrong question. Okay, yeah, so we got about the same thing. Let's see, whoa, big salad of stuff here. So f prime is greater than 0, so f prime is positive when we're less than negative 3. So we'll start with an f prime. So positives. And then negatives between negative 3 and 1. Then positive after 1. And then f prime of negative 3 and f prime of 1 are both 0. Okay, so that's pretty traditional. And then we go concave down, because negative before negative 1. Frowny face. And then after negative 1, we got Happy face. Okay, so I got a maximum at -3, I got a minimum at 1, and our transition is at -1. Our concavity transition. So this is where I should see the inflection point. So concave down, concave down, concave down, concave down, concave up, concave up, concave up, concave up, concave up. All right, and our final round. Let's see. So let's look at f prime. It's positive when we're greater than 2. It's equal to -1/2 when we're less than 2. That's down 1 over 2, right? It's giving me an exact slope that I have to follow. F of 2 is 0. So we're guaranteed a slope of -1/2 when we're less than 2. So this is where I'm actually counting this slope out, making sure it's perfect. Or as perfect as I can. Oof. Missed that by a mile. And it goes up after that. Let's see. F prime of 2D and E, so it's going to be a sharp point or a cusp or something. And then we are concave down and going up. And there we go. I hope this video has been helpful. I know it's kind of quick, but the more of these you do, the more comfortable you'll get with them. Just let me know. As always, if there's anything I can do to help, if you want to walk through a problem together, I can ask you questions and kind of lead you through it instead of just telling you everything. So have a great one.